All right, so I will practice timing these better so that I can fit everything into one video. But just to catch us up again, we were doing the ratio test for this series, and we had gotten to the point where we had reduced the limit that we were looking at. And so this first one that I circled, boxed in green, we can see that the limit of that is n squared over n squared, going to infinity, so that's going to give you a 1. 3 to the negative 1, no variables there, so it's no limit. That's the same thing as 1/3. And then we have 2 to the first, which is just 2. Notice I dropped the limit and the absolute value bars because I've taken the limit. N is no longer in the problem. And this is going to go to 2/3. Remember, we need to state why it's important. It's important because it is less than 1. So we know that the series converges by the ratio test. Now, when it comes to what work you have to show the limit setup. Notice it can be the one where you say a sub n plus 1 over a sub n. And then you have to show what that's equivalent to. You don't have to show where you originally plugged it in. You even don't have to plug in where you found the multiplying by the reciprocal. You can, if you're okay with doing it, jump straight to this step where you've multiplied by the reciprocal and matched up the corresponding parts. And then you have to tell you what the limit is, why it's important, and then of course that converges by the ratio test. I'm going to do some of those shortcuts for this next one. But go ahead and try this one on your own and pause the video. So when I look at this series, whenever you see a factorial, nope, a factorial, that is a big clue that you want to do the ratio test, because factorials simplify nicely with the ratio test. So the first thing, always have to show the setup. And so the setup for this is the absolute value of a sub n plus 1 over a sub n is equal to, and now I'm going to go ahead and do a few steps in my head. Make sure I put in the limit. So I have the limit as n goes to infinity of my expression. So I'm going to go ahead and write actually the a sub n plus 1 first. So that's going to become 2 to the n plus 1 over, I'm going to put it somewhere else, the 2n plus 1 factorial. And then I'm going to multiply this by the reciprocal of a sub n. So when I think about it, I'm doing the reciprocal of it, of the original one, and matching up the corresponding parts. So 2 to the n and 2n factorial. And then I do want to simplify the sum, and we can do some of this in our head. So for example, 2 to the n plus 1 over 2 to the n is just going to give us 2. Looking at this, we have 2 to the n factorial over, well, that's going to become 2 to the n plus 2. So I have 2 to the n plus 2, 2 to the n plus 1, stopping at 2 to the n factorial. Why we want to do that is because then we notice things cancel out. So the limit that we're actually finding is a little bit easier. It's 2 times 1 over 2n plus 2. Well, what is... Try that again. I'm wrong. Not just 2n plus 2. but 2n plus 2 times 2n plus 1, in absolute value bars. N's going to infinity, so this is 2 times this term. This whole factor is going to go to 0. It's big on the bottom. So where's it going? Equal to 0. Why is that important? It's less than 1. So it's going to converge by the ratio test. And that is the ratio test for you. The last test we have to learn is the root test. And I do want to be very clear. The root test is not part of the official BC curriculum. So if you want to exit this video now, you can. It won't be on your test, it won't be on a quiz, it won't be on the AP exam. But there are going to be some problems you may encounter where the root test is actually going to be an easier problem to do that's a little bit more difficult with some of the other tests. If you want to practice the root test, it's those pages in your textbook. I'm not assigning them, but they're on the same page that you're working on for homework number 7. So the root test. What is the root test? The root test is another limit. It's the limit as n goes to infinity of the absolute value of a sub n to the 1/nth. So when we're doing the root test, same things can happen. It can be, the limit can be less than 1. It can be greater than 1, or that limit could be equal to 1. If that limit is less than 1, it converges. If that limit is greater than 1, it diverges. And that is equal to 1, no info, and you hope that there's a better test for you to try. So I'm going to do 2 examples using the root test. Again, don't have to know this one, but I think it's a good one to know. I often use the root test when I have n in the exponent. Now, oftentimes you could do a geometric one. Why I'm going to do the nth root test is because not only is n in the exponent, but it's also in the base. So again, I'm going to go ahead and set up my limit. This is the limit as n goes to infinity of the absolute value of e to the 2n over n to the n to the 1 over n. So when we think about it, we have a power raised to a power. So we will multiply those together. This new limit is going to become the limit as n goes to infinity of the absolute value. 2n times 1 over n is e squared. That is just a constant over n times 1 over n is to the first power. So when you do that, let's go ahead and take the limit. Constant over n, so something over something really big, equal to 0, less than 1. So this is going to converge by the root test. Similar, let's go ahead and set up this other one. I have the limit as n goes to infinity of the absolute value of 1 over the natural log of n to the n to the 1/nth. Root test, n to the 1/nth, those will cancel out. So I have the limit as n goes to infinity of 1 over the natural log of n, a constant over something that's getting bigger, bigger slowly, but still getting bigger. That limit is equal to 0, less than 1. So we know I'm going to be lazy. That is also going to converge by the root test. So your homework is in the textbook. All of these problems can be done using the ratio test, or you may use any test that you wish. Remember that my answer keys are posted online. There's worked out solutions posted online. You can do the work in OneNote, and that way I can see your work and help you as you're working. I am going to ask you to submit it, so if you're working on a separate sheet of paper, you will need to find a way to take a picture of it and post it into that correct page in OneNote for me. The rest of this week, what it's going to look like is going to be just some practice days. And then there is going to be a take-home quiz that I'm going to ask you to complete, dealing with all of these convergence tests. Please, again, email me or reach out to me if you have any questions or if you need any support or extra help.